Welcome to the WhiBo Project presentation. WhiBo is a project that deals with design of white box algorithms for data mining, and the name WhiBo is an abbreviation from white box. Currently, most algorithms are designed as black boxes, which means that the users can only provide data to the algorithms, read models the algorithms make, and can sometimes adjust parameters of an algorithm. But the users perceive the algorithms as a black box. More important, users work mostly with only several standard algorithms in a field and are unaware of the components the algorithms are built of. In white box design, the user has the ability to see the structure of an algorithm. White box algorithm design enables users to construct their own algorithms by assembling algorithms building blocks together. The WhiBo project has three main objectives. The first objective is to educate students in data mining, as the students can get a better feeling of the structure of algorithms and can even design their own algorithms. They can investigate algorithms more thoroughly and analyze how changing a building block of an algorithm influences the algorithm's performance. The second goal is to serve as a community platform for sharing algorithm parts and investigating algorithms on the level of building blocks. The third goal of WhiBo is to serve as an algorithm recommender system that can help users choose the appropriate algorithm for data at hand. WhiBo includes a mechanism that can build dataset tailored white box algorithms. The idea for the WhiBo project came from architecture, where Christoph Alexander proposed the white box approach for house design. He believed that house buyers are mostly offered with only several models of houses which can fit most of their expectations. As there is a strong economic reason for doing so, Alexander also proposed, opposite to the black box approach, to collect good building blocks of house design and to share these blocks among designers so user-tailored houses could be built. Alexander also showed in several projects that this hasn't to be expensive. The basic idea was to put the user demands in first place, so the user necessities, example, someone loves to cook, likes to read, etc., determines the building blocks a house should be built of. Here is a nice solution for an entrance door with small windows around the door, which make more lights to the house and better connectedness to the outside. This idea can be reused in further projects. A nice solution for a kitchen is shown on this slide, and on this slide a solution for our living room with rounded walls is shown. Now, let's take a look at decision trees for data mining. We know that all houses have an entrance door, windows, a living room, a kitchen. The same way, there are also structures a decision tree includes. A decision tree must have the ability to create splits for either categorical or numerical data or for both. The decision tree must always have a way to select the best split from all available splits that were created. A decision tree can optionally include the criteria for stopping tree growth, example when a tree reaches a predefined depth, or to prune a tree when a tree is grown to make the decision tree more applicable on unseen data. A decision tree can also include the option to remove insignificant attributes before split creation, so the split creation space can be made smaller and an algorithm faster. On this slide, the famous decision tree algorithms and their building blocks, usually hidden from the users, are shown. We see that for the ID3 algorithm, he only includes two building blocks. For split creation, for categorical split creation, he includes multivay, and for evaluate split information gain. Other algorithms include different building blocks. The question is, what if some of assembled building blocks in an algorithm make the algorithm perform better on dataset? Well, that's no problem, we could choose a different algorithm. But what if a building block combination would make an algorithm perform great on a dataset, but that combination is not available in the famous algorithms? We would have to build new algorithms, and with a black box approach this is almost impossible, because black box algorithms are usually not designed to replace building blocks. White box algorithms, on the other hand, can combine any of these blocks. As for remove insignificant attributes, there is one building block, but there is also option not to use it. We can have two options. For numerical splits, there are 2 building blocks and the option not to use, so we have 3 options. For categorical splits, we can combine any of these, so we can have 7 options. For value splits, there are 5 building blocks, and it is a necessary building block, so we can have 5 options. For stop criteria, we can have 4 options, and for prune trees, we can have 4 options. So this makes it in total, from just combining the building blocks from these algorithms, we could produce 3,360 algorithms. We developed the algorithm designer in RapidMiner as a plugin, and this plugin enables users to design their own algorithms. The algorithm design process goes very easy. The user first has to click on a sub problem on the left side, and the solutions for this problem occur. We can choose a building block or a solution for this sub problem and save the selected building block save component, and we see that the component and their parameters will appear at the right side of the panel. Then we further select create split. Then we also choose components, building blocks we want to use, save them, and they appear on the right side. The process goes on. For a value split, we use distance measure and save the component. The component appears in here. And for prune tree, we choose minimal error pruning and set the parameters or use the default parameter, and this all appears on the right side. At the end, we can save the algorithm with the extension WBA as white box algorithm, and now we can use the algorithm in the WhiBo generic decision tree as any other algorithm and use it to create models and to extract knowledge in RapidMiner. We also developed, as there are many algorithms, we saw from a couple of slides that there are 3,360 algorithms, so there is a huge problem to select the appropriate algorithm for the data at hand. We solved this by including operator, a generic tree operator, which can select the best algorithm for the data at hand. For example, for the famous golf dataset, the best algorithm found was this algorithm, which includes no options for remove insignificant attributes, no options for stopping, and no options for pruning, but has the ability to use multi-way for categorical splits and information gain for evaluate splits. So how WhiBo solves the algorithm selection problem? We see it like that. The user has to say what he wants to do. In our case, he wants to do classification with the decision tree, and he gives a data set, the golf data set, and the evolutionary algorithm searches through the space of all components, of all building blocks of algorithms, and returns the algorithm with adjusted parameters back to the user, so the user can use this algorithm for his data. This is our project homepage, whibo.fon.bg.ac.rs. You can find there our publications. You can also follow us on various social networks and sites, and you can also download the WhiBo plugin, the WhiBo documentation, and you can also follow the news from our website. What do we plan and what we have done? Where so far WhiBo is developed for decision trees and for partitioning clustering algorithms, but in the near future we also try to use it also on other data mining algorithms, for example neural networks, support vector machines, and other, because we believe that groups of algorithms have a similar structure and can exchange building blocks between each other. We also will try to integrate meta-learning, because we believe this meta-learning could be used for faster white box algorithm selection, where dataset characteristics can also influence the search space of an algorithm. So for example, the number of attributes or I don't know, the type of attributes can determine which components should be used. Before the WhiBo project, it was not easy to exchange building blocks hidden in black box algorithms or in scientific papers, as some building blocks were never used worldwide. The WhiBo project stimulates sharing of building blocks and building of data-tailored algorithms that can adapt better to data and reveal knowledge that couldn't be mined before because of black box algorithm constraints. Thank you for your attention.